Welcome to Basic Electrical Engineering Lecture 8. We are studying nodal analysis, and today we'll study the concept of supernode for nodal analysis. A supernode appears when we have a voltage source, either an independent voltage source or a dependent voltage source between two nodes directly as the only component. There is no other component except the voltage source between the two nodes. To handle this situation, we need a skill that we call the supernode technique. For the supernode technique, here is an example. We have these nodes V1 and V2, and this 12 volt source is connected directly between the two, and we have a ground node. How to solve this problem? First, we'll assume V1 to be the first node for which we have to write an equation. We can write an equation for this branch. Since this will be written as minus 4 milliampere, because as per our convention this current is entering in this node, therefore this should be written as negative as per the convention of our textbook. This current will be assumed to be leaving because we don't know about this direction definitely, therefore V1 over 1k, but we don't know about this current because we have a voltage source connected between V1 and V2 nodes as the only component. For those cases, we need to draw a cloud around V1 and V2, and we'll consider this as one node. Since this node includes two nodes, we call it a super node. And we'll find out the branches that are connected to this cloud on its outer side. Let's see the branches connected to this cloud externally. This branch, this branch, this branch, this branch. So we'll continue writing. We have written equation for this branch. We have write down the current for this branch. We have already written down this current for this branch and this branch. There are two other branches connected to the same cloud externally. Plus the voltage on this side of the cloud is V2 over 1k plus V2 over 2k is equal to 0. Now we have written equations for this current. We have written currents for this branch and this branch. Now we have only one equation and two variables, V1 and V2. How to handle this situation? We need one more equation to find out the values of V1 and V2. Where to obtain this? It's obvious. We have a 12 volt current source, and we know that the positive side of this 12 volt voltage source, the positive side of this voltage source will be 12 volt higher than its negative side because its magnitude is 12 volt. So we can easily write the second equation. V2 is V1 plus 12, because the positive end of this voltage source will be 12 volts equal to its magnitude higher than its negative end. So now we have two equations and two variables. We can solve them simultaneously to find the values of V1 and V2. Once solved, it will give us you know how to solve this. We'll multiply this 2k throughout. This will come minus 8. This 2k multiplied by minus 4 milli. 4 2s are 8. Milli cancels with k. Milli multiplied by k is a 1. We have already seen that. Plus 2v1 plus 2v2 plus v2 is equal to 0. So 2v1 plus v2 plus 3v2 is equal to 8. This is how we can rewrite equation 1. And we know what equation 2 is. I cannot find my eraser. V2 is V1 plus 12. Now we can put the value of V2 here. If you put V2 here, this becomes 2V1 plus V2 here, 3V1 plus 12 3 is 26 is equal to 8. So it is 5V1 is equal to minus 28. So V1 is minus 28 over 5. This V1 can be put in equation. This value of V1 can be put in equation 2 to find the value of V2. So V2 is V1 minus 28 by 5 plus 12. 12 5 is 60 plus 32 over 5. This is how we can handle the situation where a supernode appears in a circuit. The student is encouraged to solve more problems related to supernode, especially when we have a dependent voltage source between two nodes. Thank you.